Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Stefan from Business Review, and I'll be your host. It is our pleasure to have Donaldson Company with us today, who will be presenting this webinar titled Electric Vehicle Evolution, Dual-Stage Venting for Battery Packs. Today's guest speaker is Shane Campbell, Senior Product Development Engineer at Donaldson Company. Before we begin, I'd like to welcome you to our webinar platform On24. You will notice that this webinar is browser-based. If you happen to disconnect for any reason, please just click on the link to receive via email to rejoin the session. In order to ask questions, you can do so via the Q&A widget on the top right-hand side of your screens. Just type your question into the box and click Submit. We'll allocate some time at the end of the session to address any questions or thoughts that you may have. Please use the yellow Help widget if you require any assistance, and keep in mind you can move, resize, and maximize any of the windows in front of you for a better view of the slides. But now, please allow me to welcome Shane.
Thanks, Stefan, and thank you everyone for joining us today. I'm excited to share with you some of the work that we've been doing here at Donaldson Company and just some of the new trends here in the electric vehicle market. So today we're going to give a brief overview of Donaldson Company. We're going to talk about why vent, the differences between single and dual stage venting. I'm going to share with you what Donaldson has to offer for dual stage battery vents, a few design considerations, and at the end we'll have a Q&A session. As Stefan mentioned, there is a Q&A box at the bottom of your screen where you can enter these questions. A little bit about myself. My name is Shane Campbell. I'm currently a product manager here at Donaldson Company. I've been with Donaldson for 7 years, mostly in a variety of engineering roles. So Donaldson Company is really a global company. We have 46 manufacturing plants all over the globe. We have laboratories, distribution centers located all over the globe as well. We have a high focus on research and development that is supported by 1,800 plus patents. We reinvest 3 to 4% of our revenue back into R&D, and we're constantly looking to grow both organically and then also through acquisitions. And Donaldson is IATF certified to support your automotive needs. So to kick things off, we'll have our first poll question.
Thank you very much, Shane. So the first polling question for today reads, on a scale of 1 to 5, how familiar are you with battery pack venting? The first option is not at all familiar. The second option is slightly familiar. The third choice is somewhat familiar. And the fourth choice is moderately familiar, with the last choice being extremely familiar. I'm sorry, Shane, I believe you cut off there for a second. Can you please try refreshing your page to reconnect? In the meantime, if I can please ask all the attendees to vote on the choice that applies to you. Simply mark the answer that applies to you and click Submit. Now let's take a quick look at the results. So we have 39.1% of people voting on somewhat familiar, and we have a split 21.7% between not at all familiar and moderately familiar. We also have slightly familiar at 17.4%. It seems like Shane is having some technical difficulties. I apologize about the delay. We'll get him back on the line shortly.
I'm sorry about that.
Absolutely no worries. Good to have you back, Shane. So the attendees voted on the polling question. And as you can see, we have pretty split results here. What are your thoughts on those?
Yeah, it's not too surprising. I was assuming that people have some bit of background on venting, or at least familiarity with battery packs in general. There's also not too many people who I would expect to be extremely familiar. So I think this is a great mix of an audience. This presentation is definitely tailored to someone who's never heard about battery venting, and also someone who is moderately or extremely familiar can still learn something from it. So that's great to see. So that leads us to our first question: why vent? So venting is required when you have an enclosure where you need to equalize pressure inside and outside the enclosure. As pressure is falling, we need airflow to be able to go into the enclosure, and as pressure is rising, we need airflow to be able to go out. At the same time, we need to keep out water, dust, and other contaminants, all while maintaining the integrity of the vent and the enclosure itself. So why vent battery packs? With battery packs, there's two ways that you can build up pressure inside the pack. The first being from temperature change during charging or discharging the pack. The battery will heat up quite a bit, or also during elevation changes, you can get pressure differentials. If you don't have a vent on there, it'll either create high pressure or a low vacuum condition, and that may lead to seal failure or deformation of the enclosure, which then could cause failure of other components. So with robust venting, we're able to help decrease the risk of component failure and also seal failure. In the diagram on the screen here, you see during normal operation, everything's sealed how we expect it. But if there is not a vent present and you create a vacuum condition, the cover can deform, creating a leak path around the O-ring or seal. So this is what we're trying to avoid, and the reason why we add vents to battery packs. One use case that we've been seeing a lot lately related to EV battery packs is all about the weight of the components present. So we know that the battery pack is one of the heaviest, most expensive EV components. And one way to reduce this is to use thinner walls, especially the lid component of the battery pack. But with this, you also get a lower maximum pressure that the pack can handle. So with venting, we're able to do two things. One, reduce the pressure that the pack sees during normal operation. And then second, we're able to help keep that enclosure at a suitable pressure throughout its lifetime. So the material that makes this all happen is our Tetra Tech ePTFE membrane. The way that this material is made, it's a polymer that is stretched that creates this filtration material that you see on the SEM image on the right side of the screen. So it has a lot of really small nodes and fibrils which capture particles, and then through a combination of the material properties of PTFE and the oleophobic coating we apply to it, it repels both water and oil, but allowing airflow to still pass through. This material is also used at Donaldson across other business units as well for different filtration needs. So now looking a little bit closer at automotive battery packs and some of the unique challenges that we face with these. The first being is thermal runaway. So thermal runaway happens when there's an uncontrolled discharge of current within the battery pack. And during this event, there's a rapid release of both gas and an increase in temperature. So we need a way to release this pressure quickly. And the ePTFE membrane by itself is too restrictive to handle this amount of venting. So we need some secondary function, and we call that active venting, which is the second stage of dual stage venting. So at Donaldson, we have two ways that we're able to achieve dual stage venting. The first stage of dual stage venting is airflow through the membrane. That's pressure equalization. But the second stage, degassing, can happen between one or two ways. The first being burst. Our product, dual stage burst, has a membrane where as pressure rises inside the pack, it pushes on the membrane, and with the assistance of pins on the cap, the membrane bursts at a specified pressure. The second method is dual stage flex. So as pressure is rising, building up inside the pack, it pushes on the vent, and we have an umbrella valve in there, which also opens at a specified pressure, allowing rapid degassing of the battery pack. So now we're going to play a video that highlights both products. All right, so from that video, there's a couple things that really stand out to me. And the first being is that dual stage venting is possible with two different methods. Whether you use a burst membrane or a flexible valve, you can achieve both passive and active venting. Also, both of these products do offer a high level of ingress protection. They will help protect against water ingress, but they are not suited for an extended period of time submerged in water. And then also with both products, there are many options available for mounting, whether you want to mount to the side of your pack, the top of your pack. We can help you find the ideal location. So now back to you, Stefan, for our second poll question.
Thank you very much, Shane. So this polling question reads, what type of venting do you currently use for your battery pack? And the options are single stage, dual stage, none, and I don't know. What results are you expecting here, Shane?
I'm actually expecting quite a mix across the board. For people who do use vents for their battery packs, either single or dual stage. But really, I think most people do achieve dual stage venting in some manner, whether it's a combination of products. So I don't have many expectations for this result. I think it could be a mixed.
Okay, thank you. And now let's take a look at the actual results. So we had 41.2% of people voting on I don't know, a split 23.5 between none and dual stage, and 11.8 selected single stage. Any surprises here?
Not quite. The I don't know is actually expected. I think unless you're responsible for that portion of the battery pack design, what type of venting is used is probably not communicated with the rest of the team. Or I suspect some people online maybe are not currently using battery vents. So that might be part of it as well. But I am happy to see that more people are using dual stage vents instead of single stage, because that really adds a lot more benefit for the health of your battery pack over just using a single stage vent alone. So very insightful. Thank you. So as we saw in the video, Donaldson has two different product offerings for dual stage vents. The first being our dual stage burst product, and the second is dual stage flex. Let's take a closer look at both of these products and how exactly do they work. The first dual stage burst battery vent, it really is made possible by the Tetra Tech's EPTFE membrane. This allows pressure equalization, the airflow in and out, but then also protection from water, dirt, and oil. It uses an injection molded plastic body, and this protects the membrane from direct spray. We use an O-ring for robust sealing to the pack wall. On this product, the retention cap has burst pins integrated in it, which help assist in the degassing function. And then finally, this product is available with a quarter turn bayonet attachment. The benefit of this is it's a really ergonomic method to install it. And as you install the product, you hear a click when it's properly installed. But we also have this tooled up in a screw fit interface. Our second product, Dual Stage Flex, is our latest release, and it is now available. So the reason why this product was developed is we had customers coming to us asking for a vent with a much lower opening pressure than we could achieve with dual stage burst. So this product offers the same level of ingress protection as dual stage burst, but through a different functionality of an umbrella valve. This design was optimized through CAE analysis, trying to balance, make sure we have the highest level of strength, we have high airflow, so during that degassing event, we can quickly get rid of the gases. And then finally, balancing airflow with ingress protection, both from submersion in water and then also spray. So the dual stage flex battery vent has a lot of similarities and one key difference when you compare it to the dual stage burst. It uses the same Tetra Tech's ePTFE membrane as dual stage burst, very similar body design as dual stage burst, and same O-ring sealing. One difference with flex versus burst is the retention cap. So instead of having sharp pins to assist in bursting of the membrane, now we have retention posts which hold the umbrella and membrane down to the body. This product uses an elastomer umbrella valve. So during normal operation, there's no airflow past the umbrella. All the airflow passes through the membrane. But as you build up high internal pressure, the umbrella will open, allowing rapid degassing. This product is currently tooled up with an M32 mounting thread. We also have a lock nut available if your pack wall is too thin to accept the M32 threads. The nut just attaches from the other side. But this can certainly be tooled up in other mounting configurations, such as the bayonet. So looking at the functionality of this part, as I mentioned, during normal operation, airflow passes in and out through the ePTFE membrane in the center of the umbrella. Once you exceed the opening pressure of the umbrella vent, you get a direct path for rapid degassing, shown here with the blue lines. But as I mentioned earlier, if you have high external pressure, that umbrella valve stays tightly sealed against the body. So when you look at both products side by side, there are quite a few differences, and depending on your application, one may be better than the other. They both have a variety of options for attachment. For typical airflow, that's referring to during normal operation where you have airflow passing through the membrane. It is a lot higher with dual stage burst, and that's because we have a larger area of membrane in that product. There's quite a big difference also with the release pressure. Dual stage flex will open by 20 millibar, where dual stage burst opens by 300 millibar. The degassing airflow are a little bit different as well, where dual stage flex gets about 15 liters per second of degassing airflow at 100 millibar, where dual stage burst, we can achieve 30 liters per second at 100 millibar. And once that membrane ruptures, it essentially creates an open hole that you can exhaust gas through very quickly. Both products provide a high level of ingress protection, and they use our Donaldson Tetra Tech's ePTFE membrane, which is both hydrophobic and oleophobic. So in terms of availability of these two products, they're both available now. The dual stage burst is in serial production. We have our quarter turn bayonet and threaded options available. Dual stage flex, we have pre-production parts which are off injection mold tool, and these can be used for any testing and validation. So now I want to talk about the top 10 technical considerations that we've discovered at Donaldson after working on battery vents for a while now. The first thing to consider is how venting assists in mitigating thermal runaway event. The vent is there for pressure equalization, but it's also there to help get rid of those thermal runaway gases as fast as possible. So consider how much gas is being produced and what the desired flow rate is of those gases. The second point, membrane permeability affects pressure within the pack. So depending on which membrane is selected and how much airflow it will allow, that will determine what pressure your pack will see during normal operations, during heating and cooling cycles. Also consider how a lighter pack structure influences venting. So as you go to a lighter pack structure, this often means a lower maximum pressure inside the pack, which also requires more venting. With vents, consider the ease of installation. Where is the vent located on the pack? What method is used to install it? Does it require many tools, many extra components? And with our design, we try to make that as easy as possible. The next 2 points go hand in hand, both the height and the weight of the vent. We try to get the most venting possible with the smallest space claim. We know how critical space claim is in your design, so we try to create the vent to be as low profile as possible, but also reduce the weight. We don't want a heavy mass sitting on a large sheet metal component that would amplify vibrations. With your design, consider the number of vents required. As you have more free air volume in the pack, it will require either a larger vent or more vents. The venting location is critical. So during thermal runaway, where do you want to degas the hot gas? So selecting that location is critical, and also a location that is good for the vent, one that is not exposed to many rocks or direct spray. Also consider your leak test procedure when selecting a vent. The vent in itself will allow airflow to pass in and out of the pack, so there needs to be some method to close off the vent during your leak test of the other components. And then finally, with hybrid vehicles, there's an additional heat source, so that heat source and its proximity to the vent can have an impact on the performance of the vent. So that is something that we like to consider, and we have options available depending if you have hybrid application. So with venting location and pack design, we suggest that you involve a venting specialist early in the process. We can work with you to find the ideal location on your battery pack for a vent. With both of our products, they are designed for ease of assembly. As I mentioned, the quarter turn bayonet, as you install it, you hear an audible click, and we have multiple leg heights to accommodate different wall thicknesses. Also available with the screw fit, very easy installation. And then if the pack walls are not thick enough to accept the threads, we can attach a snap nut from the other side. We have a unique design where if a special hole pattern is cut out, the nut can be installed from the inside, it will retain itself, and then the vent can be installed from the outside. And then both products, whether it's the quarter turn or the screw fit, can be removed and replaced with the help of a special tool. At Donaldson, quality assurance is very important to us, and the way we achieve this is through our automated line for assembly process, through the media welding. We also have an online 100% wet test to ensure that these are watertight. There are visual camera checks to ensure that the cap is properly installed and the O-ring is installed as well. And then through quality assurance, we do sampling of our parts to make sure that they are meeting critical dimensions, the release pressure is what it's specified at, that the water entry pressure is high enough, that we get enough airflow through it. And then finally, our Donaldson plants are ATF certified to the automotive standards. So just a few points on Donaldson as a partner and the value that we bring. We are truly a global company. Whether it's R&D centers, distribution centers, or manufacturing plants, we're located across the globe, so we have someone close to where you are. Donaldson has a strong knowledge of battery packs. Our engineers spend quite a bit of time keeping up to date on the latest industry trends and how that impacts venting and the needs of our customers. Donaldson has full ownership of both the membrane development and manufacturing. So one unique thing I've seen with this is as the engineers talk with customers and find new requirements, we're able to communicate that back to the R&D chemists and engineers who make the membranes themselves. And we're able to use that to come up with the next generation ePTFE membrane. Donaldson is a trusted supplier in the automotive industry. We support powertrain venting. We have mini vents out there for sensors and other automotive applications. We have tested and validated products at all stages of product development cycle. We are testing and validating our products to make sure that they are meeting the specs that we require and that they will protect your battery pack. Donaldson is very much so willing to partner. If you have a unique application, we can help you find the right product, and then in some cases, we can make a custom product unique to your application. And finally, Donaldson is constantly looking for new ways to innovate and improve our products. So most people actually know Donaldson from some of the other industries we serve. But in addition to our vending solutions, we are known in the engine for our air products, oil, hydraulics, and then a lot of our industrial applications as well. The great thing about being a diversified company like this is we're able to leverage the learning from these other business units for our venting applications. For example, we're able to take some of our coalescing technology in our fuel and hydraulic business unit and apply it for some venting applications. And likewise, we're relaying the information we learn with our venting solutions back to these other business units, and sometimes they're able to use ePTFE membrane for their filtration applications. So the way we develop products at Donaldson really starts with our corporate technology research group. This is where they come up with the new formulations of our ePTFE, our coatings research to achieve the oleophobic coatings on our membranes. We also have chemists working on absorbent materials and alternative medias for filtration. From corporate technology, it's then passed on to our venting solutions engineering team, where they come up with the core product technology that can be used across many different applications. Then our application engineers work directly with you, the customer, to find what core product is best for you. All along the way, we encourage a high level of collaboration to make sure that we are truly meeting your needs. So at Donaldson, we want to be your venting partner. We offer integrated solutions with our battery vents. We use ePTFE membrane, which is an advanced technology, and we offer exceptional global support through our manufacturing plants, distribution centers located across the globe. So now we're going to open it up to time for Q&A. You can submit your questions through the chat box, and Stefan will be moderating this session. If you have questions afterwards or would like to reach out to us directly, you can contact me or the general email address for the Donaldson Integrated Venting Solutions Group.
Thank you very much, Shane. As you mentioned, you can send your questions in via the Q&A widget on the top right-hand side, but we already have questions coming in. The first one for today reads, do these venting elements have to be serviced like oil or brakes?
Yeah, that's a great question. So they do not. So the main difference between a vent and a filter is a filter is made to collect either dust or any contaminants where a vent just keeps it out. So our parts are designed to last the lifetime of your vehicle and do not need to be serviced. In the event of a major event like thermal runaway, yes, then you would need to replace the vent, but would be many other components destroyed in that process as well.
Thank you very much for that answer. And moving on to our next question, which is it possible to integrate the valve housing into the battery housing wall and complete it with the top components?
I suppose that's possible. Typically, we sell just the secondary component that you would attach to your battery pack. I think if you integrate it with the full pack, there's greater risk there in terms of if you need to change out that component, then you're replacing a much larger part than just the vent itself.
Thank you very much for that answer. And the next question we have here is the second stage closing back by itself so that the valve can be used after one-time opening, or does it have to be changed? Excuse me.
Yeah, so I assume that's talking about dual stage flex, and that's a great question. So the vent opens at a relatively low pressure, 20 millibar. If it is just a minor event, like let's say the pack is heating up quickly and it's more pressure buildup than the EPTP can handle, it will open and close. If it's a major event like a thermal runaway where you actually have the hot gas exhausting from it, I would not say it is reusable at that point. But to answer your main question, yes, after it opens, it does close.
Thank you for that answer. And just one more reminder to the attendees, you can still send your questions in via the Q&A widget. But moving on to the next one. Am I correct that the vent bodies are made of some plastic material? If so, how does it hold up to the very high temperature of thermal runaway gases? Does it not lose structural integrity starting from a certain temperature?
Yeah, that's a great question. So yeah, we do use glass-filled plastic bodies for our component, but like many other components inside the battery pack, yes, the plastic will not hold up to long duration exposure to those temperatures, but we do design it so that the material properties and any melting of the plastic will not interfere with the degassing function. So it will allow those gases to escape, but after that event, the part is not suitable for reuse.
Thank you for that answer. And moving on to the next question, which is, do you have 3 steps venting solution?
We don't have that currently offered as a product. I know that that's something that we've talked about. How could we have, for one, pressure equalization, maybe a secondary opening function, and then a third, even further opening function? It's something that we've looked at, and it really all depends on what are the requirements of customers and how much degassing airflow they require. So far, we've been able to meet the customer needs with dual stage venting.
Thank you for that answer. And moving on to the next question. Water barrier is well understood, but what about humidity in ambient air? Will it block or limit air humidity from getting inside the pack?
Yeah, that's a great question. And a unique property about the EPTFE membrane, as you know, it blocks liquid water, but it does not block water vapor. So it really depends on the moisture vapor transmission rate, which is a property of the membrane itself. And that's really only for static environments. So as the airflow is going in and out of the pack, that moisture will travel with it. Fortunately, during times where the pack is heating up, you're building pressure inside and then exhausting, you will be able to release that moisture back into the atmosphere.
Thank you for that answer. And just one more reminder to the attendees, you can still send your questions in via the Q&A widget. But moving on to the next one. Is there a membrane that can reduce the moisture inside the battery housing?
So as I said in my last point, Yes, technically there is. If you have a membrane that allows a lower rate of transmission of vapor into the pack, there are solutions out there, and we are actively working on products that would dry the inside of the pack. I wouldn't say that's the membrane itself, but there are materials that can absorb moisture and then also release that moisture back at a more desirable time.
Thank you for that answer. The next question for today reads, you mentioned different attachment methods. Can you weigh the different methods and benefits/disadvantages of each?
Yeah, so in the presentation I talked about the quarter turn bayonet and also the screw fit. The main advantage I see with the quarter turn bayonet is how well it works with thin pack walls. So we're down to about 1 millimeter thickness, and with the different leg heights, we can accommodate that, where it is not as easy to install a threaded option. And then with the M32 threaded option, that's a great fit if you're able to mount to the side of your pack wall where you can actually tap the thicker material. It also interfaces well with different mounting tools and specified torque wrenches.
Thank you for that answer. And moving on to the next question, which is, how does a part like dual stage flex prevent against water entry?
Yeah, so with dual stage flex, there's two ways. So the first is the EPTFE membrane, which blocks both water and oil. And then the second is that umbrella valve. So even under very high external pressure, that umbrella valve just pushes against the body and seats even tighter. So we test our parts at IP67, which is about 1 meter of water for 30 minutes to determine if it is watertight.
Thank you for that answer. And just another reminder, you can still submit your questions from the Q&A inbox. And moving on to the next one. How could you estimate the amount of gas and gas pressure released during thermal runaway event? Are there any models?
Yeah, so that's a really interesting question. The way that we're able to understand that really comes from our customers and their knowledge of their battery packs. So one, what's the free air volume inside your pack? How many cells do you have inside the pack? And then if there's a thermal runaway event, how much gas is produced from the breakdown of each cell? And then also with some assumptions baked in of how many cells will that event propagate to. So from that, we can get an estimation of the total volume of gas, determine over what time period, and then that is how we back out the required flow rate for degassing.
Thank you for that answer. And moving on to the next question for today. If there is humidity in the air inside the battery pack, can it get out through the air through the vent? Together with the air through the vent, excuse me.
Yes, so air typically exits the pack whether you have high pressure inside, but a lot of time the high pressure comes from some heating event. So during that event, the humidity will exit the pack with the air.
Thank you very much for that answer. And I believe we have time for one more question for today, which is release pressure for the burst is lower than 300 MBAR. Any lower range to consider?
Yeah, that's definitely something we've looked into quite a bit. The challenge we have with going much lower for a dual stage burst product is as we start approaching the normal operation zone that you would experience for pressures, we don't want the burst pressure to be very close to that. We want to separate out those two regions as much as possible so there's no chance that there's a premature burst of the vent. So it provides a reliable function at both low and high pressures.
Thank you for that answer. And as I mentioned, I'm afraid that's all the time we have for today. In case you didn't get your questions answered today, please keep in mind they can be answered at a later date offline. So that just leaves me to thank Shane for the great presentation and to Donaldson Company for sponsoring this session. To the attendees, you'll receive an email shortly with instructions on how to watch the on-demand version of this webinar, or you can do this on our website, which is www.business-review-webinar.com. Thank you once again, and have a great rest of your day.
Thank you, Stefan, and thanks everyone for joining.